All right, now let's do some homework for section 9.1. The homework on page 830, please do problems 5, 7, 9, 11, 13, 15, 17, 21, 29, 31, 33, 35, 37, 39, and 41. And when you're done, I want to talk about some of them. So problem 9, we have cotangent t plus tangent t divided by secant minus t. Now the first thing we remember that seeing the negative t here is that for cosine and secant, these are the only even functions in the bunch. Even function means that you can throw the negative sign away like it's not there. Okay, so we'll just put a plus there. Okay, so it's no different than the other t's, and can get rid of that. So the next step we need to do is somehow simplify this thing. To simplify it, we can write everything out as sine and cosine. All right, including the tangent. So that cotangent would be is given as let's look over here. Okay, cotangent is 1 over tangent, that is flipping tangent around. Tangent is sine over cosine. So let's write that down. Tangent here is equal to sine x over cosine x. Sorry, t. It's not. We're not doing x right now. We're doing t. So let's get rid of that thing. So this is sine t cosine t. And then cotangent is flipping tangent upside down. So cotangent is cosine t, t divided by sine of t. And then secant is 1 over cosine. Okay, so we'll write down secant as 1 over cosine of t. So then this is the long division. So to divide is to invert and multiply. Okay, so then let's write down the numerator right here as cosine of t over sine of t. That is cotangent. Okay, and then plus sine t over cosine t. That is tangent. Cosine t times, okay, flipping this thing around, times just multiply by cosine of t. Now that would become something like, let's get this to come out to be, this multiplied together becomes cosine squared of t, that times that, over sine of t, plus, this one cancels out, okay, plus sine of t. Okay, so then and what else is there to do? Well, we can put the common denominator, because if we do, we'll put a sine of t right here too. Then this will become sine squared, right? Because it was sine of t before, which is sine squared over sine that gives us what it had before. So this is equal to cosine squared plus sine squared equals to 1. That's one of our fundamental identities. So being the sine squared plus cosine squared equals to 1, we'll write down 1 up here. And the bottom is sine of t. And that would be the answer. Okay, that should be as simplified as it gets. However, if you wish, you can also write 1 over sine. 1 over sine is cosecant by definition. Okay, cosecant is flipping sine upside down. So this is also cosecant, c, which spells CSC of t. So that either answer should be acceptable. Now let's see. Let me check what the book says. Okay, the book's answer at the back of the book is choose cosecant t as the right answer, because it's the most elegant one. It isn't 1 over something. Okay, and when I say elegant, I mean simple most of the time. And so that is the answer for problem 9. So next, let's look at problem 13. Now problem 13 says we have 1 plus tangent squared over cosecant squared plus sine squared, and then 1 over secant squared. Okay, so let's deal with that. Now first, 1 plus tangent squared says right here, 1 plus tangent squared equals to secant squared. So let's write that in. Okay, so this part equals to secant squared. So we have secant squared theta, and cosecant squared cosecant is the same as 1 over sine. So we'll just write it out as to divide by cosecant is the same as multiplying by sine squared theta. So I'll write it right there. Okay, this is the cosecant. This part, okay, that is the cosecant, and then and this part is 1 plus tangent squared. And the next thing is then we have plus sine squared theta, and then 1 over secant squared. 1 over secant is cosine squared. Okay, that and right here I should probably have said this is 1 over cosecant squared. That is the same as sine squared, because 1 over cosecant is sine squared, and then 1 over secant is cosine squared, because this is 1 over secant squared. So this is cosine squared theta. All right, and then there's a formula that says no, there is not. Let me see. But there's a formula for this, right? Here is sine squared plus cosine squared here, and that is equal to 1. That's our Pythagoras theorem. Okay, so this is equal to 1, and that's sine squared. Secant is 1 over cosine, so this is the same as sine squared over cosine squared, which is tangent squared. Okay, so this whole thing is tangent squared theta plus 1, and being the secant squared is equal to 1 over cosine, so this is sine over cosine, which is tangent. Now tangent squared plus 1 is by this rule right here, okay, is equal to secant squared. So this equal to tangent squared plus 1, and that equals to secant squared, and that is our solution, should be anyway. And I checked the answer, and that is correct. Problem 13. Yeah, the problem here says it is in terms of theta, but the answer is in terms of x. I think the author forgot that he was using theta, but that's okay. The point is the answer is secant squared, and that's problem 13. So next, let's look at problem 17, where we have secant x plus cosecant x divided by 1 plus tangent x, and we want the result in terms of sine x. So we want everything to somehow got turned into sine x for some reason. So let's give that a try and see how that happens. Now we'll change everything into sine and cosine in this case, especially since our result's supposed to be in sine x. So turning this into sine or cosine, this thing, secant is 1 over cosine. Okay, so this is 1 over cosine x, plus cosecant is 1 over sine. Okay, cosecant is 1 over sine, C as cx, and then divided by 1 plus tangent is equal to sine over cosine. So that is we'll have sine x over cosine x. No, this should be sine x. I said cosecant x is 1 over sine x. Why do I have that there? Let me fix that. Okay, let's see. This should be sine x. Okay, now we are going to, first we're going to do the numerator by writing down the common denominator. We're going to combine the denominator into 1, so then just this part. Okay, inside here, we're looking at just this part on top. That would be, we'll multiply the what's on the bottom together. So we'll have cosine x, sine x, and so this part becomes sine x, okay, and then and that part becomes cosine x plus cosine x, because when you do division, then this cancel this part out, becomes 1 over cosine x, and then cancel that part out, becomes 1 over sine x, and then this part becomes times. Flip this thing around. After first we turn it into a fraction, okay, and that would make it becomes so the 1 becomes cosine x as well. If we extend this thing, then we can change the 1 into cosine x. like this, cosine x, because then cosine x cancel out, cosine x will become 1. So that is that's how that works out. So then when we're doing division here, to divide is to invert and multiply. So let's flip this thing around, so then cosine x will go on top, cosine x, and this stuff stays down there, cosine x plus sine x. And then now notice that sine x plus cosine x is here, and also here, same thing, cosine x plus sine of x. So these things can cancel out with each other. Similarly, the cosine x cancel out with this one, and then we only have sine x left at the bottom. So the answer is 1 over sine of x. And they specifically says the answer has to be in terms of sine of x. So then the answer has to be this. If it doesn't say that, we could express it as cosecant like we did before. See, that's the same story. But this time they want it to be in sine of x, so that is our answer. Next, let's look at problem 21, where we have secant x plus cosecant x, and then, well, give me a second here. Yeah, I want to write it in the blue marker. That way it is, you know that this is being multiplied to the next one, okay? Next, times sine x plus cosine x, and then minus 2, and then minus cotangent x equals to something. All right, so let's do that. But first, we are going to convert these things to sine and cosine, just so that things are more consistent. So to rewrite this thing, secant is equal to 1 over cosine. We'll write that down. So this is, I'll start over here because it's a big long line. So we have 1 over cosine x, the secant one here, plus cosecant is 1 over sine, okay? So let's write that, 1 over sine of x. That's the first two things, times, this part doesn't change. This is sine x plus cosine of x. And then minus 2 and minus cotangent. Cotangent is the 1 over tangent, which when tangent is sine over cosine, so cotangent is cosine over sine. So we have cosine x over sine of x. Okay, so that's that. And the next thing we're going to do is multiply this whole thing out. So first, we'll take each term here, we'll multiply with each term here once, okay? So first we'll do this one. 1 over cosine x will multiply with sine x, and that will give us sine over cosine, which is tangent. I'll write it that way, okay? Because our answer is supposed to be in terms of tangent. So anytime we see a tangent, we'll turn it into tangent. Otherwise, we'll just keep it what it was before, keep it as sine and cosine. And so that's this is multiplied by the first one. Next, this thing times that thing is equal to 1. Next, this one's up, okay? This one times the first one, that's also 1. And then this one times second one is equal to, that's cosine over sine. Tangent is sine over cosine, so cosine over sine is 1 over tangent x. So I write it this way, tangent x. And then we're going to minus 2. And then minus, see, this is cosine over sine, which is 1 over tangent x. 1 over tangent x. So we have, right now, we have plus 2, minus 2, that's 0, okay? Plus 1 over tangent x, minus 1 over tangent x, that's also canceled out. So the only thing we have left is tangent x, and that should be our answer for problem 21. And I'm looking at the answer at the back of the book, and it is, okay? So that is, that's for problem 21. Okay, so problem 31, we need to show that 1 plus sine squared over cosine squared equals to 1 plus 2 tangent squared. In other words, we are trying to prove that this is the same all the time. What we can do is just manipulate this thing until it comes out to be the same on both sides. That means it must be true. And now what I mean by that is something like this. Then let's see. Okay, so we have on this side, we can write it as 1 plus 1 over cosine squared, 1 over cosine squared x, okay, plus sine over cosine will be tangent squared x. And that equals to 1 plus 2 tangent squared x. Okay, and at this point, you notice there's a tangent squared x and a tangent squared x here, and we can cancel that out, and that equals to, so this one's gone. We have only one left here, 1 plus tangent squared x. So this one is canceled out, okay, and we have only one left here. And the 1 over cosine squared, we can write it as secant squared x. Now, is this statement true? Because if this statement is true, then this is true and that is true. Now, is secant squared equal to 1 plus tangent squared? And we look over here and see tangent squared plus 1 equals to secant squared. This is indeed true. Therefore, we have done the proof, because we have arrived at a rational statement that's true for all cases, and therefore the original statement is also correct, because the original statement can be derived from here, okay? Like starting here, we can add a tangent x to both sides, and then we'll get to that equation. Okay? Just working it backwards. Anyway, that is one way to prove problem 31. Okay, next let's look at problem 37. We're trying to figure out if tangent x divided by secant x times a sine of negative x happens to equal to cosine squared x. That's a new one. I've never seen that before. Okay, that instead of proving an identity, they're asking us to figure out if it actually is an identity. All right. So to figure that out, we'll have sine of, if there's a minus sign in here, except for cosine, which is even, and you can ignore the negative sign, all other negative sign has to come out on the side. So we'll take the negative sign out and change all these things into sine and cosine. So we have, so we do what we normally do, which is write everything in terms of sine and cosine. So this is 1 over secant. Okay, secant at the bottom is the same as cosine on the top. So so we'll change the secant into the cosine on top, and then the tangent is equal to sine x over cosine x. So as you can see, the cosine x is going to cancel themselves out. Okay, and then there's a sine x here, but except that the negative sign, we need to take it out. So we'll stick it all the way out here. So that should, and the cosine x is canceled out. So this whole thing then equals to sine negative. Okay, don't forget this thing here. I tend to forget it. Sine squared x. Okay, what do they want again? This is problem 37, and I lost my. We need to ask, the question is, does that equal to cosine squared x? No, it does not. There's sine squared x equal to 1 minus cosine squared x. It doesn't just, minus it. Sine squared x doesn't automatically equal to cosine squared x. So the answer is, so we have disproven it. Okay, so this is not equal to cosine squared x in general. Maybe never. I don't know. Anyway, but we'll think about that later. The point is, this is not true. So that is also the answer at the back of the book. Okay, the problem 37 is that this is not an identity. So it is false. Okay, next. All right, so next let's look at problem 39. We have this situation here, and we just have to we'll do cross multiplication. If it ends up being an equality in the end, then we'll know that this equality stands. If it ends up with something ridiculous, then we know this is not true. So let's do cross multiplication. Going this way, we'll have cosine squared x, okay? Cosine squared x. equal to, now multiplying this way, remember the negative sign of sine will come out right here to turn this thing into a minus sign. So this becomes 1 minus sine x. This is 1 plus sine x. So we'll use this formula to see when you have a minus and a plus, that's just equal to them being squared with a minus in the middle. So this becomes 1 squared, which is 1 minus sine squared x. And 1 squared is just 1. 1 minus sine squared x, see, 1 minus sine squared is cosine squared. So this equal to cosine squared x. See? And as a result, these two are the same. Okay? And this is indeed true. Cosine squared is equal to cosine squared, which means this statement is also true. Therefore, the answer to problem 39 is that it is true. Okay? And that marks the end of this section.